Of this study guide with the answers, because it does get a little crazy in here when we're going over the study guide, and some people don't get the information they need to feel fully prepared. So I'm making this video with nobody in the classroom, no distractions. You're going to watch this video during class today, and then after you've finished the video, if you have questions, you can come see me. We can write down some clarifying things on the study guide. I would recommend anything I write down here, you write down. And if you need to pause because you didn't have something filled in, then by all means pause, okay? All right, so let's look here at this first question. It says, determine if each relation is a function. So remember, this is where we're looking at the x values to decide, is it a function or not a function? It says, use complete sentences, justify your answer with words, numbers, and or symbols. Okay, so we're gonna look at here and we're gonna focus just on these x values. And we're gonna ask ourselves, do any of these x values repeat? They do not. So that means that yes, this is a function. And the justification of our answer would be, this is a function because the x values do not repeat. Right? What that means, x values not repeating, is that every input has one output. Okay, so let's move on to the second one. Now we have a graph, and we're going to look at this graph and we're going to ask ourselves, is this a function? And this is where we had the vertical line test, right? So if I were to draw a vertical line anywhere on this curved part of the graph, if it goes through more than one point, so let's say I drew it here, right? Does everybody see how it goes through twice? So that tells me that those x values repeat. That means that I have a point at 5 and 4 and 5 and negative 4. Okay, so that means that the x values would repeat. Because those x values repeat, that means it's not a function. And so how am I going to justify this? Well, I used my vertical line test. The function failed the vertical line test. Right? And we proved that by writing the ordered pairs of these points, so we could also compare those. All right, let's look at this next one. Is this relation a function? Again, we're going to focus on only the x values. The y's don't matter. And because it looks like these repeat, the fours and the negative 4s and negative 2s repeat, that means that that is not a function. And our reason would be the x values, negative 4 and negative 2 repeat, meaning they have more than one output. Okay? Let's go ahead and look at the next page. All right, we have a table showing the amount of water remaining in a pitcher as it's poured into a sink over a 10-second period. Okay, so we have our x values. Notice that the x value is the title of my x-axis, and the y values are the title of my y-axis. Okay, that's a huge component of algebra. X's go along the horizontal axis, y's go along the vertical axis. So I'm going to go ahead and plot these. So these are basically ordered pairs, right? So I have my first order pair is 0, 500. So I'm going to plot. Oops, I need to fill this in. They tell me this goes by ones. And then because this first increment is 50, I know this is going to increase by 50. So now I can go ahead and plot. So 0, 500. My next ordered pair is going to be 2, 450. So over 2 up to 450. My next ordered pair is going to be 4, 300. Go over to 4 up to 300. My next one is going to be 6, 150. I'm going to go over to 6 up to 150. And then 850 is this one right here. And then the last one is 10, 0, right? And this right here is where the water bottle is empty, right? Remember we did the hot chocolate and the hand sanitizer examples, okay? So over time, the water bottle is now empty. So when I graph this, if I connect all these points, I can see very clearly that this is nonlinear, right? Because it clearly does not go in a straight line. So when it asks me, is this relationship graphed above linear? No, this is not linear because, and you could say it's not a straight line. You could say it doesn't have a constant rate of change, right? If all I was given was this graph, and I look here and I'm like, or this table, and I'm like, oh, well, this is increasing by 2s, but this is going down 50, down 150, down 150, down 100. This is not a constant change here, right? The difference between these numbers is not the same. So this would automatically disqualify it from being a function, or excuse me, being linear, right? The x's work, but the y's don't. So that's how we have to decide if it's linear or not. So functions only have to do with x's. Linear has to do with the constant rate of change for x's and y's. Okay, next page. All right, we've got Jordan here, and he has all of his photos on a memory card, right? A lot of us don't have to deal with that anymore because we have the cloud, but it's a thing. Below is a summary of the backup process. So before we go ahead and graph this function, let's fill in our graph. So we know this is going by minutes, by single minutes. And then the memory card in megabytes is going by 200s. So I'm going to have 400, 600, 800, and so on. So I've got that all filled in. I'm going to label my x and y axis. Ooh, that's a really ugly y. All right. And now I'm going to go through these, and I'm going to go ahead and sketch it, just like we did with people going on a walk with their dog or people mountain biking, all that stuff. Okay, so it says in the first 3 minutes, Jordan added 800 megabytes of photos at a constant rate. So at 3 minutes, we're going to go up to 800 megabytes. I'm going to check that off up here because I did it. Jordan had to pause the backup and spent the next 4 minutes locating the remaining photos he needed. So that pause, let's go ahead and connect this. That pause would be like somebody no longer walking or somebody no longer biking, taking a break. So I'm going to pause for 4 minutes. 1, 2, 3, 4. So nothing is happening, but time is still passing, right? We're on the clock. Time doesn't stop just because he has to go look for his other photos. Jordan saved the remaining 1,000 megabytes of photos in the next 2 minutes. So that means he has 1,000 more. So we're going to add 1,000 to the 800 because he has another 1,000 and it was 2 minutes. So I'm going to go over to 9 and up to 1,800 because it's 2 more minutes and another 1,000 photos, 1,000 megabytes of photos. Finally, Jordan realized that some of the photos were duplicates, so he deleted 400 megabytes of photos at a constant rate during the next minute. So now he's gone back down here to 1,400 because he had to delete some that were duplicates. Okay, so this is what your graph should look like. This last bit of information is just telling us that the only amount he could have on his memory card was 2,000. This is not really important information. This doesn't really affect our graph, okay? It was just for reference. So hopefully you have this, like, I don't know, I think it kind of looks like a giraffe, like maybe missing like a leg right here and like a little tail, and like, does everybody see the giraffe? Yeah. Okay. The next page. Ooh, matching up sketches of functions to a story. All right, so remember we talked about paying really close attention to the x and the y. Okay, we've got our time. We don't know how much time. And we have distance from home. So this person is going away from their home. And hopefully you notice right away, they never go back home, right? They never came back down to the x-axis. So we know they are still far away from home. Okay, so let's look at our choices. Opposite Dan's home is a hill. Dan climbed, this should say Dan. Oh no, I guess it's Dion. I'm sorry, I read that wrong. Dion climbed slowly up the hill, then walked across the top, and then ran quickly down the other side, away from home. Okay, so this could show him climbing, walking across the top, and then running quickly down the other side. I mean, it could. He's still away from home, so A is a choice. Dion left her home. I'm sorry, Dion is a girl. I am sorry, guys. Dion left her home for a run, but she was unfit and gradually came to a stop, not at home. Okay, so I think we can cross this one out because this doesn't look like Dion is stopping, right? Dion is still going. This is showing that they are getting away from the home. Stopping would have been just here. This could have been a stop, right? So if it ended right here, then that might be a good option, but it didn't end here. Dion is still running, so we're going to cross out B. That can't be the answer. Dion walked slowly along the road, stopped to look at her watch, realized she was late, and then started running towards her destination, not home. Okay, so do we think that this one is showing Dion climbing slowly up a hill, walking across the top, and then running quickly down the other side? Or do we think that Dion is walking slowly along a road, stops to look at her watch, realizes she's late, and then starts running? I'm going to go with C on this one. I'm going to say she's slowly walking, stops to check her watch, and then picks up the pace. Okay, so I'm going to say C on this one. Either way, she never made it back home. All right, how about this one? We've got distance from home and time. This person does make it back home. Okay, so we know that this person walked away from their house and then came back to their house. Lily ran from her home to the bus stop and waited. She realized she missed the bus, so she walked home. Opposite Lily's home is a hill. Lily climbed slowly up the hill, then walked across the top, and then ran quickly down the other side away from home. Whoa, away from home. Okay, we know she actually is back at home, so we can cross out B here. Lily left her home for a run, then she was unfit and gradually came to a stop. Not at home. Again, she's not at home. So it can't be this one. So it has to be she ran from her house, waited at the bus, realized she missed the bus, and then she slowly walked home. Do you see how this is less of an incline, right? This is steeper. So this tells us that she was running, and this tells us that she is walking home, probably upset because she's got to call mom and dad and figure out how to get to school. So we're going to say A is the story that goes with that one. All right. Here, almost the last page. Here we go. We have cars in a parking garage. Number of cars, right? This shouldn't say stored. This should say parked. In a parking garage one day. So this is how many cars came into a parking garage in one day. First thing we're going to do is fill this in. At 2 p.m., 3 p.m., 4 p.m., 5 p.m., and so on. And then this is how many cars are actually in the garage. So it looks like we're going by hundreds. All right, we're going to look for an interval where the rate of change is constant. So 12 to 1, this is definitely not constant. It's a curve. 3 to 6, so I'm going to go like this, 3 to 6. Again, not constant. 9 to 10, right here, this little window, that is a straight line. That is constant, so our answer is going to be C here. Write yourself a note, straight line. And also that it changes, right? Because a horizontal line is not a change. Circle the interval of the time interval below where the function is nonlinear. So between 1 and 3, let's look here. That looks pretty linear to me. Between 3 and 6, that looks nonlinear to me. That's a somebody who could possibly be the answer. And then 6 to 9, that is also considered linear, but it's not a constant rate of change. It's just there. That's how many cars are there. So we're going to go with 3 to 6 because it is a curved line. All right, and that's our signal. Circle the time interval below where the function is decreasing. So 12 to 1 is decreasing. That could be 1. 1 to 3, increasing. So that's not going to be our answer. And 6 to 9, nothing's happening, right? So it's going to have to be 12 to 1. What ordered pair represents the maximum value? So our highest point on the graph is right here, and it's 12, 800. And what does that represent? That tells us that at 12 p.m. there were 800 cars. And I know that because this is what the 12 says, and we know that this is the number of cars. What ordered pair represents the minimum value? So all the way over here at 10 p.m., this is our lowest point on the graph. So it's going to be 10 and 100. And what does that represent in this situation? 10 p.m., only 100 cars left. And again, I get that from the graph because it says 10 p.m. and it says 100, and this represents cars. All right, last page. The function y equals 45x models the number of revolutions y a record player makes in x minutes. Okay, so remember, we're talking about independent and dependent. What does the independent variable and what does the, oops, this should say dependent variable represent? So x is our independent, and that is our minutes, right? And y is our dependent, and that is our revolutions. And some of you might be saying, Mrs. Marsh, how did you know that? You're so smart. Well, it says revolutions, y, and it says x minutes, right? So as long as you know that x is the independent, right, those are your parents, minutes will determine how many revolutions the record player goes, right? So however many minutes I listen, the more minutes, the more revolutions. Less minutes, less revolutions. So it will say in the question what y is and what x is. Oh, you guys, I didn't read the question carefully. Oh, man. I'm going to erase this. I'm sorry. This is annoying, and I apologize. Okay. What is the independent variable in the situation, and what does it represent? So x, independent, and it represents minutes. Y, dependent. So basically it's the same thing I had written there, but I just had in one spot, and this is revolutions. So we just had to split that up there into the two separate things. I apologize for that. I jumped ahead of myself. All right, according to the function, how many revolutions would the record player make in 15 minutes? Okay, so x, remember, is the 15, is the minutes. So y, the revolutions, equals 45x. So y will equal 45 times 15 minutes. So y is going to equal, let me get out my calculator here, 675 revolutions. Right? So that would be my answer. Okay, and then everybody's favorite part, fair game review. We have some fractions here. Let me grab my Desmos calculator to remind everybody how to do this on Desmos. So remember, we're really lucky because we can use this and it does all the fraction fanciness for us. So these parentheses tell us we're going to distribute, which means to multiply. So negative 1/6 times x plus, and now I have to do negative 1/6 times 5. So I'm going to do a fraction, negative 1/6, and then I'm going to multiply that, times 5. And so I get this really weird number, and then I'm going to hit that converter, right? This goes from decimal to fraction, and I'm going to get negative 5/6. So I'm going to erase this plus sign, and I'm going to get negative 5/6, right? I don't have to have the plus sign there. It's gone because now I have a negative value. It's greater than or equal to 6. Okay, so now I'm going to draw my wall of equality, and this is being subtracted, so I'm going to add 5/6, add 5/6. These are now gone, so I have negative 1/6 x is greater than or equal to. So I'm going to clear out, and I'm going to do 6 plus 5/6. And I'm going to get this pretty cool decimal, and then I'm going to change it into an improper fraction. So that's going to be 41/6. Right? And now this is being multiplied, right? Negative 1/6 times x. So the inverse of that is to divide by negative 1/6. So I'm going to divide by negative 1/6. This is my division right here, making it into a fraction. So I'm going to, on my calculator, let's clear this, fraction 41/6 divided by negative 1/6. And I'm going to get negative 41 as my answer. Oh, here's the announcements. Just a second.
WMS today is Wednesday, December 7th. I'm Brandon Farrington, and I'm Madison Swizzle from the Badlands team. Please stand and join us for the Pledge of Allegiance. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. Please remain standing for the moment of silence. In recognizing the humanity of our fellow beings, we pay ourselves the highest tribute, Thurgood Marshall. Remember that no one is always learning, responsible, respectful, and safe. Make good choices and have a great day, Wes.
Well, that was pleasant. Okay, so we have an inequality, so I'm going to graph this. And remember, you only need 3 points on your graph. You need the number, 0, and its opposite. And since this is greater than or equal to, I'm going to close this, and I'm going to show that it's going greater than or equal to. All right, last question. We're going to use distributive property. 2 times negative x gives me negative 2x. 2 times negative 10 gives me negative 20. Plus 7x equals 25. Draw my wall of equality. I've got some like terms here. So negative 2 plus 7 is going to give me a positive 5. Remember, I just combined them because they're on the same side. Minus 20 equals 25. I've got subtracting 20, so I'm going to add 20 to the other side. I've got 5x equals 45. Divide by 5 on both sides. X equals 9. So that is your study guide. There will be no funny business tomorrow. It'll be very similar to this. Now that you've watched this and you have a complete study guide, if you have any questions, come see me. Thank you.